Hi, my name is Oscar, and I'm here to make a short presentation on some of the issues that we've been encountering in our mining operations. Now, some of these issues have been documented in our technical report. However, the report talks about optimizing our instrumentation in order to improve data collection. And now we know that if we improve our data collection, we will be able to deal with some of the process inefficiencies that we're facing, some of the data inconsistencies and data quality, and also to address productivity. During our investigations, we determined that a few of our mining components are providing us with not so reliable data in, in, in the sense that they are providing us with some data discrepancies. Some of the data don't provide us with enough information, and some of our sensors are not well equipped enough to handle our ever-changing work environment. Now, some of these components have been determined to be the conveyor belt monitoring system that we have, the haul truck cycles monitoring system, shovel cycle monitoring system, and an alkalinity levels monitoring system. So the current conveyor belt system that we have can measure weight of ore, but however does not account for moisture, and it doesn't have a wide enough temperature for our working environment. Temperature ranges only from plus 35 to minus 15 degrees Celsius. So the recommended conveyor belt we have come up with is a VM 100 belt scale system from Watts. Now these conveyor belt can provide us with accurate weight measurements. It has a high accuracy of plus or minus 0.25%. It also gives us a high volume accurate measurement as well. It has a much higher temperature range, plus 45 to minus 60 degrees Celsius. And the VM 100 belt scale system has extra features such that it is very simple to install. It has a stationary and mobile application. So basically you can hook it up to a phone or a laptop and work remotely from the field. It has multiple communication protocols. It has optical belt scale for volumetric scale calculations. So now for the haul truck cycles monitoring system. Now our current system only tracks and records haul truck loading at shovel. It uses GPS and a GIS for motion and location. But however, we do need a more robust system. We do need a system that is able to not just tell us when the haul truck is at the shovel, but to actually track and record the entire hauling process. So we have come up with a system called a low right H2250 system. Now this system consists of a pressure transducer, an angle sensor, an indicator, and a modem and GPS. And now there's a picture of how it actually works. So the pressure transducer is actually installed on the struts of the haul truck, on all four struts. So these struts basically measures the weight that is being applied to it when you load up the truck, and basically that's the weight of the load. So these sensors are very accurate, and the angle sensors are actually installed on the chassis of the haul truck. So these angle sensors, what they do, they provide us with angle information as regards to uneven ground and when the haul truck is moving up and down slopes. So this gives you a more accurate reading of the load as the trucks go through uneven roads and uneven environment in the mine. The indicator is installed in the cab for the haul truck operator to basically track and view the load that it's carrying. And lastly, it's the modem and GPS. Basically, this just works as to locate where the trucks are, just to give the position of the trucks and the motion of the trucks. The next system we'll talk about is the shovel cycle monitor system. The current system that we have right now just tracks the shovel loads and proximity detection. But what we do need as for a system is a system that can not only do all of these, that is to track loads and proximity detection, but to also track and tell us more about the wear and tear of the shovel buckets, uh, rock, rock fragmentation analysis, and payload monitoring system. So here we have a picture of the haul truck system that we're proposing. So basically, a sensor is going to be attached on the top of the shovel, and here is the camera. It's a sensor that scans through the load that the shovel digs up. Basically, it does a rock fragmentation analysis, and it plots, gives you real-time plot of the various rock sizes that the shovel has just picked up. Now, this is good information for our drilling and blasting program, so that it gives us we can give them a feedback on how well or how fine the particles have come out after blasting. The next picture you can see there is basically a payload monitoring system, whereby the sensors are being installed on the hydraulics of the shovel. Basically, the hydraulics there are the ones measuring the load that's being dumped onto the haul truck. Also, another cool feature about the payload